In this video, we'll look at how to solve compound inequalities. A compound inequality is defined as two inequalities that are connected by an and or an or. So here are three examples of compound inequalities. The first one reads x is greater than 6 or x is less than or equal to -1. So notice the word or joining those two inequalities. The second one, x is less than or equal to 7 and x is greater than 3. So there you'll see the word and. And then the third example, -5 is less than x is less than 14. So we're going to see that that third example, even though the word and isn't written, that is what we call an and inequality. So we're going to talk about the difference between an and an or inequality. We'll look at how to graph each of those, how to solve them, represent them in set notation, represent them in interval notation. We're going to begin with the or inequalities. When you think about an or inequality, you're thinking about the union of two inequalities. So union, I want you to think join two things together, kind of like just combining, adding two things together. The solutions to an or inequality have to satisfy at least one of the inequalities. So there could be a number that satisfies one inequality but not the other, or there could be a solution that satisfies both. And all of those together are the solutions for the entire inequality. When you're graphing, you're going to graph both inequalities on the same number line. They might overlap, they might not overlap. All right, so let's begin with the graphing first. So in each of these three examples, the variable x has been isolated, so we don't have to work to isolate the variable at all. We're just looking at the graphing. So three different cases. Let's look at the first one. X is less than 0 or x is greater than or equal to 6. So my suggestion is to draw your number line. Make sure that both of these numbers are placed on the number line in the right relationship to each other. So we have 0, we have 6, 0 is smaller than 6, so I'm going to place 0 to the left of 6. If you don't fill in any other numbers, you don't have to worry about a scale, so you could just place those two, just make sure they're in the right relationship to each other. Alright, so I want to think about each of these inequalities. This is an or, so I'm going to graph them both on the same number line. They could overlap or they could not. For the first one, x is less than 0. It's not including, so we'd use parentheses. Less than means I would be shading to the left. So at 0, I have parentheses, and then shading everything to the left of that. That's going to keep going, so my arrow will show that. The other inequality, x is greater than or equal to 6. So greater than means I'm shading the numbers that are bigger than 6. This greater than is only in relationship to that 6. And then since it can be equal to, we have a bracket at 6. Let's practice writing this in interval notation as well, since we have the graph. So we have two different pieces that are graphed, two different pieces that are shaded, so we'll have two different parts of our interval. The first interval would go from -infinity to 0, parentheses around both of them in this case. The second interval would go from 6 included, bracket around the 6, to +infinity. And we would have parentheses around infinity. When we're writing intervals and we want to join two intervals, instead of using the word or, we use the union symbol. So this big U stands for union. It's a set notation symbol. In the second example, x is less than or equal to 5, or x is greater than -1. So again, I'm going to place those two values on a number line. -5 is smaller than -1, so make sure that's on the left. And for the first inequality, x is less than or equal to -5. So I'm shading all the values that are less than -5, but equal to, so I'm using a bracket. at -5, shading to the left. I'm shading all of this here. My arrow shows it keeps going. And on the other side, x is greater than -1. Not equal to, just greater than. Parentheses at -1 and larger. So again, if I wrote the interval, I'd have two different intervals. First one would be from -infinity up to -5. Bracket around the -5, parentheses around the infinity. Union, parentheses, -1, comma, infinity, parentheses. All right, let's take a look at the third example. Here we have x is greater than 9, or x is greater than 3, or greater than or equal to 3. All right, so on my number line, I have 9 and 3. 3 is smaller, so 3 will be on the left. 9 is on the right. I want to be greater than 9, or greater than or equal to -3. So notice that both of these inequalities are going in the same direction, so my shading will both be going to the right for both of these numbers. So at some point, though, that shading is going to overlap. So the first one, x is greater than 9, greater than, doesn't say equal, but greater than would be here. I would put parentheses there. I'm not going to put it yet because I want to see what's happening here because I notice that that's also going in that direction. X is greater than or equal to 3. So if I go to the 3, it can be equal to 3, so bracket, but it can be greater than. So this shading is going to eventually match up with that shading and then keep on going. So the shadings would overlap here, but since it's an or, any of the values that we've shaded in would work for this compound inequality because as long as it works for one, it works for the whole thing. So some numbers like 5 would be in this region here. 5 makes the statement true. Doesn't make that statement true, but it's okay. And I don't have to put the parentheses at the 9 because I'm really actually then including it when I shade it in for this set. So your graph would be that one piece, that one interval. It would go from 3 to positive infinity.